Hi, thank you for reaching out with your question. I had a moment, so I went into your MyLive account and pulled up this question for you. I hope it's the same numbers. It doesn't always come up with the same numbers for me as it does if you had sent it to me. So in the future, if you do have a question on homework, go over to where it says question help here, and there will be an option to ask my instructor. You can type in your message there, but it'll also send me the exact question that you have with the numbers, because the questions are toggled from student to student, so you have the same concept but slightly different numbers. So here we are. We have refer the accompanying data set and use the 30 screw links to construct a frequency distribution. Begin with a lower class limit of 1.470 inches and a class width of 0.010 inches. The screws were labeled as having a length of 1.5 inches. And you can click on the icon to view the data. So I clicked on this icon and it gave me this data table over here, which is what we'll be using later to fill in our frequencies. But first we have to start with our class lists, or widths, not lists. So we know that the width is equal to 0.010. You can just call it 0.01. So if we know the class width, we know that that's the amount that I take from one lower limit and add to get to the next lower limit. So 1.470 plus 0.01 would be 1.480 plus 0.01 gives me 1.490 plus 0.01 will give me 1.500 plus 0.01 will give me 1.510. So there you have it. You have your lower class limits. Now we need to find the upper class limits. The upper class limits will also be 0.01 apart, or the class width apart. So we know here that the first class contains all of the numbers from 1.47 to before the second class starts at 1.480. We also know that we are asked to round to the nearest thousandth. So why don't we just take all of the numbers that are 1,000th before the next class starts. So let's take 1.480 and subtract 1,000th. Excuse my alarm, I'm sorry. So 1.480 and subtract 0.001. And we'll get 1.479. So the first class goes from 1.470 to 1.479. We can use the same strategy to get the next one. We know that the second class ends before we hit the start of the third class at 1.490. So let's take 1.490 and subtract 0.001, or 1/1000th, and we get 1.489. Notice that these are 0.01 apart. So we can follow the pattern of adding our class width, 0.01, to get the rest of our upper limits. So we'll have 1.499, and then we'll add 0.01 to that, and we'll get 1.499 plus 0.01, or 1.509, and then we'll have 1.519 for the last upper limit. So we have our class limits. We have the lower limit and we have the upper limit for each class. Now, to complete the frequency distribution, what we need to do is we need to take all of the numbers in the data table here, and we need to classify them into one of the listed classes. We do that by first creating a tally. You can do that on scrap paper, and then we'll write in the frequencies on the squares. I'll help you get started with the tally for the frequencies, and then I'll pause the video, fill it in, and we can check our work together. So first we have 1.483. 1.483 falls in the second class, so I'll put a tally there. 1.502, that's between 1.500 and 1.509. 1.492, third class. 1.501, fourth class. 1.497, third class. 1.513, second class. So I'm going to pause the video, finish the tally, and then we can check in together. As you can see here, I've taken all of the actual screw lengths in our table, and I've tallied them next to a frequency. Now we can write in the numbers. So the first class had 4, the second class had 5, the third class had 10, the fourth class had 9, and the fifth class had 2. So here we have it. We have a frequency distribution of the actual lengths of the screws. So what this is looking at, it's a data set for 30 screw lengths. These screws are listed or sold as 1.5 inches, but after measuring, you can see the distribution of them to the nearest thousandth of an inch. Hopefully this helps you to create your own table for a frequency distribution with a lower limit and upper limit. Remember, to get the upper limit, we knew we were rounding to the nearest thousandth, so we just took the next lower limit, subtracted 1/1000th to get the upper limit for the first class, and then we followed the pattern of the class width to get the rest of the values in that column. Please reach out if you have any more questions at all. I hope you found this helpful. Have a great day.